Hello everyone, I am Ishan from University of Central Florida, and here I am presenting our work SPAct, Self-Supervised Privacy Preserving Action Recognition. This work is done with Dr. Chen Chen and Dr. Mubarak Shah. So here is a brief overview of this presentation. So first I will talk about privacy leakage in action recognition, then motivation for self-supervised privacy removal, SPAct framework, results, ablations, and qualitative results. Action recognition is a problem of classifying human action based on spatiotemporal understanding of video. It has many growing applications in real world, for example, video surveillance camera, smart shopping systems like Amazon Go, or elderly person monitor systems. For example, in this elderly person monitor system, goal is to recognize daily actions like eating, laying down, or taking pills. Since we know that edge computing is not feasible, videos are shared to the computation cloud, and while doing that, we end up sharing a lot of private information like gender, skin color, clothing, etc. Let's go through all existing approaches. Our goal is to anonymize video in such a way that it can be useful to train action recognition model. It removes privacy attributes, and since we know that these kind of privacy annotations are costly to annotate, we want to avoid its requirement. So first set of methods is downsampling based method. We can still see a lot of private information uncovered here, so that's not desirable. Second set of methods are object detection based obfuscation methods. So it reduces action performance, so that's also not desirable. So there is a recent work from Wu et al. Which works really well, but it requires private C attributes annotations. So that's why we propose our self-supervised framework, which performs as good as this supervised method, and it doesn't require any private information labels. So here is a schematic of our proposed framework. Our framework comprised of mainly three components: FA, anonymization function; FT, utility branch or action recognition branch; and FB, budget branch or privacy removal branch. So first step is network initialization. So anonymization function FA, which is encoder-decoder based model, which is unit, which is initialized with the identity weights. Action recognition branch is a 3D CNN model, which is initialized with the raw video and its action labels. And privacy removal branch is a 2D CNN model, which is pre-trained with the contrastive self-supervised loss. To optimize our framework, we use a Minimax optimization strategy. First, we take the initialized models, then freeze FT and FB, and update FA in such a way that it minimizes LT loss and it maximizes LB loss. So we know that self-supervised loss LB, it helps in learning all spatial cues, and maximizing it destroys all such information. So at the same time, we are retaining the information which is useful for action recognition. If we just keep FT and FB frozen, then FA learns some trivial anonymization. So to prevent that, we minimize both LT and LB in the next step, where we keep FA frozen. Now, to better understand this, we can set some analogy with GAN training. So if we consider FA as a generator, FB as discriminator, and FT as some constraint of GAN. So in the first step, FA tries to fool FB, and in the second step, FA becomes more stronger to avoid fooling of FA. So in the experiment section, protocols are mainly based on action and privacy classification from the learned anonymization. So action performance should be retained and privacy classification should be degraded. So first we study prior protocols, which involves human action recognition datasets like UCF101 and privacy dataset like Whisper. We also study new protocols like non-human privacy, which includes private information of scene and object. And we also evaluate on 24 times bigger dataset for robust evaluation. So first we show results on this known action and privacy protocols on multiple datasets. So from this trade-off plots of action and privacy, we can say that our method, it achieves competitive performance to a supervised method. For novel action and privacy protocol, our method surpasses supervised method and achieves state-of-the-art. So these are output videos from various methods. We can observe that our method and supervised method, it anonymizes so well that even human eye can't really guess the private information correctly. To summarize our contribution, we want to highlight that we are the first one to propose privacy preserving action recognition framework, which is self-supervised. Our approach gets competitive action privacy trade-off compared to the supervised method. And for novel action and privacy attributes, our method achieves state-of-the-art.